Welcome back, everyone, to the Deep Dive. I'm so excited for today's topic.
Me too.
As always, we're taking a deep dive into a fascinating subject.
Right?
And today, it's all about numbers.
Numbers are everywhere.
You use them every day, whether you realize it or not.
Exactly. From counting your toys to figuring out how much change you get at the store.
We're going to explore the amazing world of arithmetic.
It's going to be a fun one.
We've got our trusty Wikipedia article on arithmetic ready to guide us.
A classic.
We're going to uncover some truly amazing things.
Like what?
Like how old arithmetic actually is.
Oh, wow.
The different types of numbers out there.
That's a lot.
How computers do math.
I've always wondered about that.
And maybe even some ancient counting tools.
Like an abacus.
You have to wait and see. But first things first, what exactly is arithmetic?
Well, according to Wikipedia, arithmetic is the branch of mathematics dealing with the basic operations of numbers.
That sounds a bit complicated, but
It's really not.
yeah, it's actually something you use every day.
Exactly. Like imagine you have a collection of toys
Okay, I have toys.
and you get more as a gift.
More toys.
To figure out how many toys you have in total, you use addition.
It's as simple as that.
Or let's say you're sharing cookies with your friends.
Oh, I love cookies.
To make sure everyone gets the same amount, you use division.
Sharing is caring.
So arithmetic is all around us.
It's the building blocks of math.
Now I'm curious, where did the word arithmetic even come from?
Well, the word arithmetic comes from the ancient Greek word arithmos.
Arithmetic.
And guess what it means?
What?
Number.
Wow. So like a secret code word passed down through generations of mathematicians.
That's a great way to put it.
Speaking of ancient times, did you know that civilizations like the Egyptians and Sumerians were already using arithmetic over 5,000 years ago?
Really? That long ago?
That's right. They needed arithmetic for all sorts of practical things.
Makes sense.
Like the Egyptians used fractions in land surveying.
Land surveying, yeah. Especially after the Nile flooded, and they needed to reestablish boundaries.
Oh, so they could figure out who owned which piece of land.
Exactly. And the Sumerians, they developed a system that influenced our timekeeping.
Really? What system is that?
The base 60 system.
Base 60.
Yep. They divided an hour into 60 minutes and a minute into 60 seconds.
Wow. So their math is still impacting us today.
It's amazing, isn't it? These ancient civilizations really had a strong grasp of arithmetic. But it wasn't just about practical applications.
It wasn't.
The ancient Greeks, they took things a step further.
How so?
Well, they started thinking about numbers in a more abstract way.
Abstract.
Yeah, like as ideas and concepts.
Interesting.
They were fascinated by the relationships between numbers.
Oh, like how they fit together and form patterns?
Exactly. They were really laying the foundation for more complex mathematical ideas.
Wow, so they weren't just counting things, they were trying to understand the bigger picture.
Precisely. Now, we can't forget about a very important contribution to math.
Let me guess, 0.
You got it.
It seems so simple now, but it must have been a big deal back then.
Imagine trying to do math without a zero.
I can't even imagine.
Well, we have the ancient Indians to thank for developing the concept of zero.
And they also created the decimal system we use today, right?
That's right. They revolutionized mathematics and made it much easier to work with numbers. It's amazing how these ancient civilizations shaped our understanding of numbers. But now I'm curious, how do computers do math?
Computers. They use a system called binary arithmetic.
Binary arithmetic.
Yeah, it's like a secret code.
So every time we click a button or watch a video, we're sending a secret code to the computer.
Pretty much. It's all based on the simple principles of arithmetic, but on a massive scale.
That's incredible. It makes me wonder, if arithmetic is so fundamental to computers, what other hidden powers might numbers hold?
That's a great question, and one we might just find the answer to as we continue our deep dive into the world of arithmetic.
Stay tuned. So we've talked about how ancient civilizations used arithmetic.
And how computers use it too.
But now I want to talk about the numbers themselves,
Oh yeah, the numbers.
because there are more types of numbers than you might think.
There are. More than like 1, 2, 3.
Oh, way more. It's like having different tools in a toolbox.
I get it.
You wouldn't use a hammer to screw in a light bulb.
Right. Different tools for different jobs.
Exactly. So let's start with the most familiar ones. Natural numbers.
Natural numbers.
Yeah. Those are the numbers we use for counting. 1, 2, 3, and so on.
Oh, like when I count my toys.
Exactly. They're the basic building blocks of arithmetic.
Got it.
But what if you don't have any toys to count?
That would be sad.
Well, that's where whole numbers come in.
All numbers.
They're just like natural numbers,
Okay.
but they include 0.
So if I have 0 toys, I still have a number to describe it.
Exactly. Now, let's say you borrow a toy from a friend,
Okay, borrowed a toy.
and you promise to give it back later.
Right.
Now you owe your friend a toy.
I'm in debt.
That's where integers come in.
Integers, what are those?
Integers include all the whole numbers,
Okay.
but they also include their negative counterparts.
Negative counterparts, like
Yeah.
opposites.
Yeah, like +1 and -1.
So if I owe my friend a toy, I could say I have -1 toys.
Precisely. Negative numbers are useful for representing all sorts of things,
Like what?
like debts, temperatures below zero, or even moving backwards.
Wow, negative numbers are pretty cool.
They are. Now let's move on to rational numbers.
Rational numbers.
Have you ever shared a pizza with friends?
Of course. Pizza is the best.
When you slice that pizza into equal pieces,
Yummy slices.
you're using fractions.
Fractions, I know those.
And fractions are a way of representing rational numbers.
So if I cut the pizza into 8 slices and I eat 3, I've eaten 3/8 of the pizza.
Exactly. Any number that can be written as a fraction, where the top number is an integer and the bottom number is a non-zero integer, is a rational number.
So all those fractions I learned in school, 1/2, 3/4, 7/8, those are all rational numbers.
That's right. Even whole numbers can be rational numbers,
Really?
because you can write them as a fraction with a denominator of 1.
Oh, I see. So 5 is the same as 5/1.
You got it. Now, Wikipedia also mentions irrational numbers.
Irrational number, what makes them irrational? Do they not make sense?
Well, they're called irrational because they can't be represented as a simple fraction. One of the most famous irrational numbers is pi.
Pi. Like the pie I eat.
Not quite. This pi is a mathematical constant.
What does it do?
It's used to calculate the circumference of a circle.
The what of a circle?
The circumference is the distance all the way around the circle.
Oh, okay.
And the pi, it goes on forever.
Forever.
Its decimal representation never ends and never repeats, which is what makes it irrational.
No wonder it's called irrational. It just keeps going and going.
Another famous irrational number is the square root of 2.
Square root of 2.
It represents the length of the diagonal of a square with sides of length 1.
I don't quite get that one.
Don't worry about it. For now, the important thing is that irrational numbers exist,
Okay. So we have all these different types of numbers.
and they all work together.
How so?
They make up something called the set of real numbers.
Real numbers.
It's like a giant family of numbers. But even with all these different types,
Right.
the basic operations of arithmetic remain the same.
So I can still add, subtract, multiply, and divide all these different types of numbers.
That's right. No matter what kind of number you're dealing with,
cool.
you can still perform those basic operations.
It's like they all speak the same language.
Exactly. A universal language of math.
Yeah.
Speaking of which, we mentioned some other math terms earlier,
Like what?
like exponentiation roots and logarithms.
This sound complicated?
They can be, but they're really just extensions of the basic operations we've already talked about.
Okay, can you explain them a little?
Sure. Let's start with exponentiation. Think of it as a shortcut for repeated multiplication.
Repeated multiplication.
Yeah, like if you wanted to multiply 2 by itself 5 times,
Okay.
instead of writing 2 times 2 times 2 times 2 times 2,
Right, that's a lot of 2s.
you could simply write it as 2 to the power of 5.
2 to the power of 5. That sounds cooler.
It is. Now, roots are the opposite of exponentiation.
Opposites, like how addition and subtraction are opposites.
Exactly. It's like going backwards.
Backs.
Yeah. Like if
Okay.
you know that 3 multiplied by itself is 9,
Okay, 3 times 3 equals 9.
you can say that 3 is the square root of 9.
So it's like figuring out what number was multiplied by itself to get the answer.
Exactly. Now, logarithms, they're a bit trickier,
Oh, no.
but they're really helpful for solving certain types of problems.
Like what?
Like if you want to figure out what exponent was used in an exponentiation problem.
I see. So if exponentiation is like building a tall tower, logarithms are like figuring out how many blocks were used to build it.
That's a great analogy. Logarithms can be a bit like mathematical detectives,
Awesome. So we've got these basic operations and then these more advanced ones.
and they all work together to help us understand the world of numbers.
It's pretty amazing.
It is. But, people weren't always able to do these calculations so easily.
What do you mean?
Well, before calculators and computers existed, people had to come up with other ways to do math.
Really? Like what?
We'll talk about that after a quick break. It's really amazing to think about how arithmetic has evolved.
Oh yeah, from ancient times to now, it's come a long way.
It's the foundation of so much in our world, from building pyramids to modern computers.
And we use it every single day without even realizing it.
It's incredible to think that something as simple as counting
Yeah, like 1, 2, 3.
can lead to such complexity and innovation. But speaking of the future,
The future of arithmetic.
what do you think computers will be able to do with math in the years to come?
Well, that's a big question. But one thing that's really exciting is quantum computing.
Quantum computing.
It has the potential to revolutionize how we solve problems.
That sounds pretty intense. What is quantum computing exactly?
So imagine a computer that can be in multiple states at the same time.
Multiple states. I thought computers were all about zeros and ones.
That's how traditional computers work, but quantum computers are different.
How so?
They use the principles of quantum mechanics to do calculations in a completely new way.
Quantum mechanics.
It's a branch of physics that studies the behavior of matter at the atomic and subatomic level.
Whoa, that sounds complicated.
It is, but the basic idea is that quantum computers can be in a superposition of states.
A superposition.
It means they can be both 0 and 1 at the same time.
Whoa, that's mind-blowing.
I know, right? And because of that, quantum computers can solve problems that would take traditional computers millions of years.
Wow, that's incredible. What kind of problems can they solve?
Oh, all sorts. They could help us develop new medicines, design new materials, and even create artificial intelligence.
Wow, so quantum computing could change the world as we know it.
Absolutely. It's still in its early stages, but it's a really exciting field to keep an eye on.
It definitely is. Well, this has been a truly fascinating deep dive into the world of arithmetic.
It has.
We've learned so much,
We have.
from its ancient history to its potential future with quantum computing.
And who knew numbers could be so interesting?
It's clear that arithmetic is more than just numbers on a page.
Right.
It's a fundamental way of understanding the world around us.
And it's something we use every single day.
So thank you for joining us on this incredible journey.
It's been a pleasure exploring the world of arithmetic with you.
And we hope you'll continue to count, calculate, and explore the amazing world of math.
Keep those brains working.
Until next time, on The Deep Dive.